Good day. My name is Amala Nandagoval and my metric card number is TG22081. So today I would like to present about water pollution, which is electrochemical versus pH electrode sensor. So, water pollution is referred to the contamination of water bodies such as rivers, lakes, groundwater, and ocean by harmful substances. So, these pollutants include industrial chemical, sewage waste, agriculture runoff, heavy metals, plastics, and microorganism. Water pollution occur when these contaminants are released into water source without proper treatment. So, this causes changes in the physical, chemical, and biological properties of water. As a result, the water becomes unsafe for drinking, irrigation, aquatic life, and domestic use also. So, one of the key indicators of water pollution is change in water quality parameters such as pH level, dissolved oxygen, and chemical concentration. So, monitoring this parameter is essential to detect pollution at an early stage and prevent serious environmental and health hazards too. Water pollution has serious effects on the environment, like pollutants such as chemicals, sewage, and industrial waste reduce the oxygen level in water. And the low oxygen can kill fish and other aquatic organisms. Toxic substances can also accumulate in aquatic plants and animals, distributing the food chain. So the agriculture runoff causes excess nutrient and it will which causes algal blooms. These blooms block sunlight and further reduce oxygen, destroying aquatic ecosystem too. So this is lead to a loss of biodiversity in water bodies. In long term, water pollution contaminates soil and groundwater, which also negatively affect the surrounding vegetation. So now let's talk about the impact of water pollution on human health. So drinking or using polluted water can lead to serious waterborne diseases such as cholera, typhoid, and dysentery. So the chemical pollutants and heavy metals like lead and mercury can damage organs and affect the nervous system. The long-term exposure to polluted water may causes chronic illness, and water that highly acidic and or alkaline can lead to skin irritation, eye problems, and digestive issues. Continuous exposure to these contaminants also increase the risk of chronic disease and cancer, making communities that relied on untreated water particularly vulnerable. There are two sensors for detecting and monitoring water pollution. So the first one is electrochemical sensor and the second one is pH electrode sensor. So the electrochemical sensor it detects the chemical pollutants by measuring the electrical signals from reaction at the electrodes. Then it will monitor the heavy metals and then toxic chemical, dissolved oxygen, nitrates, and etc. It will be suitable for the real-time continuous monitoring in rivers, lakes, and wastewater. The pH electrode sensor is measure water acidity or alkalinity. Then it will indicate pollution from industrial discharge, chemical spills or sewage. It will be used in water treatment plants, environmental monitoring, labs, and industries as well. Okay, then next let's look at the working principle of electrochemical sensor. This sensor detect pollutant through chemical reactions, specifically redox reaction, which generate an electrical signal. An electrochemical sensor typically consists of three electrodes: the working electrode, the reference electrode, and the counter electrode. During the chemical reaction, electrons flow between the electrodes, producing a current or voltage that is directly proportional to the concentration of the pollutant. These sensors are highly sensitive and are commonly used to detect heavy metal, toxic chemical, and dissolved oxygen in water. Now, now let's discuss the pH electrode sensor. This sensor measures the concentration of hydrogen ions H plus in water. It uses a glass electrode that is sensitive to changes in pH. When the electrode is immersed in water, it generates the voltage difference due to the difference in H plus concentration between the water and the sensor's internal reference solution. So uh, this voltage is then converted into a pH value. Then a pH value below 7 indicate acidic water. If the pH is equal to 7 is neutral and pH is greater than 7 is alkaline. So importantly, sudden changes in pH are strong indicator of water pollution. Finally, let's look at some solution to mitigate water pollutions. First thing is sensor-based monitoring. Using electrochemical and pH sensor, we can monitor water quality in real time. So, this allows for early detection of pollutants and quick corrective action. Second is wastewater treatment. Treating in industrial and domestic wastewater before discharge helps remove toxins, heavy metals, and harmful microorganisms, and preventing them from entering neutral water sources. Third one is industrial pollution control. So industry should adopt eco-friendly production methods and follow the environmental regulation. One site sensor can help monitoring pollutant discharge and ensure compliance. So together, this measure can significantly reduce the water pollution and protect both the environment and human health. In last page, I got attached the sources and references. So you can have a look in Google by searching these links. So the first one is World Health Organization, which we call WHO, Water, Pollution and Health. So by clicking the links, we can redirect to the page and we can read the information over there. They got a lot of information about this. And the second one is United Nations Environment Program, which we call UNEP. So same thing, we can click the link and overview over there. And then our Environmental Protection Agency, which we call EPA. And then also National Geographic Water Pollution. So there are four links we can refer to about this project. We can refer about this title. That's all. Thank you so much. And I also got attached my transcript.